What if we're not alone in the universe? For centuries, humanity has gazed at the stars, wondering if other worlds might harbor life, civilizations beyond our own, perhaps even looking back at us across the vast cosmic ocean. Today, that question isn't just philosophical. Science has given us the tools to search for answers, and what we've found is nothing short of staggering. Out there, among the countless stars, lie planets that could be home to alien life, worlds with oceans, atmospheres, and conditions that might just cradle life as we know it. The hunt for these distant havens has led astronomers to discover thousands of exoplanets, but only a handful stand out as true candidates for harboring extraterrestrial beings. So what makes a planet capable of hosting life? It's not just about being the right distance from a star, though that's crucial. Scientists look for worlds nestled in the Goldilocks zone, where temperatures are just right for liquid water to exist. But there's more: stable climates, protective atmospheres, and even the chemical building blocks of life must align. Some planets have towering ice sheets hiding vast subsurface oceans, while others might have skies thick with gases that could nurture strange, unknown forms of biology. The possibilities are as endless as they are thrilling, and that's where our journey begins. From scorching super-Earths to frozen moons with hidden seas, we're about to explore 30 of the most promising worlds beyond our solar system, places where life, in some form, might already thrive. Some are eerily familiar, almost like Earth's long-lost twins. Others defy imagination, with conditions that challenge everything we thought we knew about survival. This isn't just a list, it's a voyage to the edge of possibility, where each discovery brings us closer to answering humanity's oldest question: are we truly alone? Buckle up, because the universe is far stranger and far more alive than we ever dreamed. Kepler 186f wasn't just another exoplanet, it was a revelation. When astronomers first spotted this distant world in 2014, it marked a turning point in the search for life beyond Earth. Here was a planet almost the same size as our own, tucked perfectly into the habitable zone of its star, where temperatures could allow water to flow freely. Picture a world bathed in the dim, reddish glow of Kepler 186, a star cooler and smaller than our Sun. Days there might feel forever tinted with the hues of sunset, yet beneath that alien sky, the conditions could be just right for life to take hold. What makes this planet so special? For starters, its size. Kepler 186f is only about 10% larger than Earth, making it one of the first truly Earth-like worlds we've found. Unlike gas giants or scorching super-Earths, this is a rocky planet, a place where continents could rise from vast oceans, and where an atmosphere might cling to the surface, shielding potential life from the harshness of space. Its orbit takes roughly 130 days, placing it far enough from its star to avoid blistering heat, but close enough to escape an eternal freeze. Scientists suspect that if water exists here, it wouldn't boil away or lock into permanent ice. It could pool, flow, and swirl, just as it does on our own planet. But Kepler 186f isn't a mirror of Earth. Its star, a red dwarf, is far more active than our Sun, frequently erupting with violent flares that could strip away atmospheres or bombard the surface with radiation. Yet life is stubborn. On Earth, extremophiles thrive in boiling vents or frozen wastes, proof that biology can adapt to the unlikeliest corners. If organisms exist on Kepler 186f, they might have evolved defenses against the star's tantrums, perhaps sheltering beneath thick ice or in deep subterranean oceans. The real magic lies in the unanswered questions. Does this distant world have clouds, rain, or even vegetation? Its reddish sunlight could paint photosynthesis in entirely new colors, with plants that thrive on infrared instead of the light we know. For now, Kepler 186f remains a tantalizing mystery, a silent reminder that the universe is full of surprises. and that the first true Earth twin might already be waiting in the data, daring us to look closer. Just 4.24 light-years away, practically next door in cosmic terms, orbits a world that could rewrite our understanding of life in the universe, Proxima Centauri b. Discovered in 2016, this rocky planet dances around Proxima Centauri, the closest star to our Sun, making it the nearest known exoplanet to Earth. Imagine stepping outside on a clear night and pointing to Alpha Centauri, that twinkling duo of stars in the southern sky. Proxima, too faint to see with the naked eye, lurks nearby, its tiny companion holding a secret, a planet that might just have the ingredients for life. What makes this world so fascinating? For starters, it's roughly the same mass as Earth, orbiting its star in the habitable zone, that sweet spot where temperatures could allow liquid water. But here's where things get strange. Proxima Centauri is a red dwarf, a star far smaller and cooler than our Sun, which means its habitable zone is incredibly close. The planet completes an entire orbit in just 11 Earth days, likely tidally locked, with one side forever bathed in dim, reddish light and the other plunged into eternal night. Picture a world divided. On the day side, perpetual twilight might nurture strange, slow-growing life adapted to faint sunlight, while the night side could harbor pockets of warmth near geothermal vents where subterranean oceans churn beneath icy crusts. Yet the challenges are immense. Red dwarfs like Proxima Centauri are notorious for their violent outbursts, unleashing flares hundreds of times stronger than anything our Sun produces. These cosmic tantrums could strip away atmospheres or bombard the surface with deadly radiation. But life has a way of enduring. If Proxima Centauri b has a thick atmosphere or a global magnetic field, it might shield potential organisms from the worst of the stellar fury. Some scientists even speculate that life here could thrive underground or in deep oceans, sheltered from the chaos above. The real kicker, we might not have to wait long to learn more. Breakthrough initiatives like Starshot aim to send tiny, laser-propelled probes to this very star system within our lifetimes. If successful, we could get our first close-up glimpse of an alien world, one that might whisper answers to humanity's oldest questions. Proxima Centauri b isn't just a scientific curiosity. It's a beacon reminding us that the universe's greatest mysteries might be hiding right in our cosmic backyard. Among the most tantalizing discoveries in the hunt for habitable worlds is TRAPPIST-1e, a rocky planet nestled in a system that feels almost designed to capture our imagination. Located 39 light-years away, this Earth-sized world orbits an ultra-cool red dwarf star alongside 6 siblings, 3 of which also sit comfortably in the habitable zone. Picture a cosmic neighborhood where planets pass so close to one another that standing on TRAPPIST-1e's surface, you might see neighboring worlds hanging in the sky like oversized moons, their geological features visible to the naked eye. What sets this planet apart isn't just its size, though that's critical, but its extraordinary stability. Unlike the turbulent orbits of many exoplanets, TRAPPIST-1e follows a nearly circular path around its star, ensuring consistent temperatures that could keep water liquid across its surface. Scientists estimate it receives about the same amount of starlight as Mars does from our Sun. But with a thick enough atmosphere, this world could trap just enough heat to create temperate conditions. Imagine sprawling oceans reflecting the dim, cherry-red glow of its star, or continents wrapped in misty, perpetual twilight. The TRAPPIST-1 system itself is a marvel. All 7 planets are packed closer to their star than Mercury is to the Sun, yet because the star is so faint and cool, 3 of them, including TRAPPIST-1e, occupy the Goldilocks zone. This cosmic arrangement raises mind-bending possibilities. If life exists on one world, could it spread to others through meteorite impacts, as some theories suggest happened in our own solar system? The planet's tight orbits might even allow for atmospheric exchange, sharing chemical precursors that could jumpstart biology across multiple worlds. But challenges linger. Red dwarfs like TRAPPIST-1 are prone to violent flares, and without a protective magnetic field or robust atmosphere, radiation could scour the surface. Yet here's the twist. TRAPPIST-1 is unusually quiet for its kind, offering a quieter, more stable environment than many of its stellar siblings, combined with the potential for tidal heating, a process where gravitational forces flex the planet's interior, creating subsurface warmth. This world might harbor hidden oases of life beneath icy shells or within deep sea vents. The true allure lies in what we might soon discover. With systems like TRAPPIST-1 prime targets for the James Webb Space Telescope, we could soon analyze the atmospheres of these worlds for signs of water vapor, oxygen, or even industrial gases hinting at alien civilizations. TRAPPIST-1e isn't just another exoplanet, it's a testbed for our wildest dreams of cosmic companionship, a reminder that the universe may be teeming with neighbors we've yet to meet. LHS-1140b doesn't just sit in the habitable zone, it practically owns it. Discovered in 2017, this super-Earth is a heavyweight contender in the search for alien life, boasting a combination of features that make it one of the most promising candidates we've found. Orbiting a quiet red dwarf star 49 light-years away, this planet is about 1.7 times the size of Earth but packs 6.6 times the mass, making it far denser than our own world. That density hints at something extraordinary, a metal-rich core wrapped in a thick, possibly life-sustaining atmosphere. What makes LHS-1140b stand out isn't just its location in the Goldilocks zone, it's the way it clings to its assets. While many exoplanets around red dwarfs face the brutal reality of atmospheric erosion from stellar flares, this planet's gravity is so strong it might hold onto its air like a cosmic vault. Scientists suspect its atmosphere could be dense enough to create a greenhouse effect, trapping heat and maintaining surface temperatures that allow liquid water to persist. Imagine a world shrouded in perpetual haze where the sky glows a deep amber and rain, if it exists, might fall slowly under the pull of intense gravity. But here's the real kicker. LHS-1140b star is unusually calm for a red dwarf. Most of these stars are tempestuous, unleashing radiation that can strip planets bare. Yet this one flickers with remarkable stability, offering a gentler environment where an atmosphere and any potential life could endure. If water exists here, it might not just linger in isolated pockets. It could form vast global oceans, shielded from space's harshness by that thick atmospheric blanket. Some researchers even speculate that the planet's high density points to a mineral-rich crust, possibly feeding hydrothermal vents that, on Earth, teem with extremophiles. The mysteries don't stop there. Because of its size and proximity to Earth, LHS-1140b is a prime target for next-generation telescopes like the James Webb Space Telescope. Soon we might peer into its atmosphere, hunting for traces of water vapor, methane, or even oxygen chemical signatures that could hint at biological activity. This isn't just another exoplanet, it's a laboratory for testing the limits of life's resilience. Whether it's a waterlogged world or a shrouded enigma, one thing's certain: LHS-1140b challenges our assumptions about where life could thrive and how strange it might look under an alien sky. Kepler-442b stands as one of the most Earth-like worlds we've ever discovered, a rocky planet with striking similarities to our own, yet bathed in the golden light of an alien sun. Located over 1,100 light-years away in the constellation Lyra, this exoplanet orbits a K-type star, a cousin to our Sun but slightly cooler and smaller. What makes Kepler-442b extraordinary isn't just its placement in the habitable zone, it's how closely its conditions mirror Earth's, offering a tantalizing glimpse of what life might look like under a different sun. Size matters when it comes to habitability, and Kepler-442b nails it. At just 1.3 times Earth's radius, it's likely a rocky world with enough gravity to hold onto a substantial atmosphere. But the real magic lies in its orbit. A year here lasts 112 Earth days, placing it squarely in that sweet spot where temperatures could allow liquid water to pool on the surface. Unlike planets around red dwarfs that suffer from extreme tidal locking or violent flares, Kepler 442b's K-type star provides a gentler, more stable environment, a cosmic oasis where life might have the luxury of evolving without constant stellar upheavals. Sunlight here would feel familiar yet undeniably foreign. The planet receives about 70% of the light Earth gets from our Sun, casting its landscapes in a perpetual golden hue. For comparison, that's similar to Earth's daylight levels on a slightly overcast afternoon, enough for photosynthesis, but with a twist. Plants, if they exist, might evolve broader leaves or darker pigments to capture every precious photon. Imagine forests of deep emerald or even violet, their foliage adapted to harness the star's cooler glow. The potential for photosynthesis isn't just speculation. Studies suggest Kepler 442b scores higher on the Earth Similarity Index than even some of the most famous habitable zone exoplanets. Its star emits enough radiation in the right wavelengths to power the chemical reactions life depends on, while its longer lifespan K-type stars can shine for tens of billions of years, offers biology an unimaginably long runway to develop and thrive. Yet challenges remain. The planet's gravity, slightly stronger than Earth's, could shape life in unexpected ways: stouter trees, denser organisms. And while its star is stable, it's not without occasional flares. But if life has proven anything on Earth, it's that biology finds a way, whether in sunlit meadows or the crushing depths of ocean trenches. Kepler 442b isn't just a mirror of our world. It's a canvas for nature's creativity, a place where the rules of life might be rewritten under an alien sky. With upcoming telescopes poised to study its atmosphere, we may soon discover whether this golden world holds the first whispers of life beyond our solar system. Kepler 62f isn't just another exoplanet, it's a water-world fantasy turned scientific reality. Discovered in 2013 by the Kepler Space Telescope, this distant planet sits about 1,200 light-years away in the constellation Lyra, orbiting a star strikingly similar to our own Sun but slightly cooler and smaller. What sets Kepler 62f apart is its uncanny combination of size and placement. At 1.4 times Earth's radius, it's one of the most Earth-like planets ever found in the habitable zone of a Sun-like star. But here's where things get fascinating. This world might not just have water. It could be absolutely drenched in it. Picture a planet where continents are rare jewels scattered across a global ocean. Kepler 62f's size suggests it has enough gravity to hold onto a thick atmosphere, which, combined with its 267-day orbit in the Goldilocks zone, creates ideal conditions for liquid water to dominate the surface. Unlike Earth's balance of land and sea, this world might be a true oceanic planet with shallow archipelagos and submerged mountain ranges breaking the monotony of endless waves. The climate could be remarkably stable too. Its star, Kepler 62, lacks the violent flares of red dwarfs, offering gentler radiation that wouldn't constantly threaten to evaporate its seas or shred its atmosphere. But what kind of life could thrive here? On Earth, oceans are bustling metropolises of biodiversity, from sunlight-drenched coral reefs to the alien-like ecosystems around deep-sea vents. Kepler 62f's potential global ocean might host similar wonders, creatures adapted to permanent aquatic life, perhaps even intelligent beings evolving in a world without dry land. Bioluminescence could dominate in deeper waters where sunlight struggles to penetrate, creating dazzling displays beneath icy crusts or thick atmospheres. The planet's axial tilt and rotation speed remain mysteries, But if they're anything like Earth's, Kepler-62f might experience seasons' gentle shifts in temperature that could drive complex weather patterns. Imagine monsoons lasting for months over lone island chains or polar ice caps that grow and recede with the years. With no large continents to disrupt ocean currents, planet-wide currents might flow unimpeded, distributing heat evenly and creating a climate far more uniform than Earth. Yet challenges lurk beneath the waves. Without significant land masses, nutrients crucial for life might be scarce near the surface, forcing ecosystems to cluster around underwater volcanic activity or river-like currents that carry minerals from submerged trenches. And while stability is a plus, a too uniform climate could slow evolutionary pressures, potentially limiting biodiversity compared to Earth's dynamic environments. The real magic of Kepler-62f lies in its possibilities. It represents an alternate path for planetary evolution, one where land is the exception, not the rule. As telescopes grow more powerful, we may one day detect the glint of sunlight reflecting off its oceans or analyze atmospheric gases hinting at biological activity. Until then, this distant water world remains a canvas for our imagination, proving that the universe doesn't just copy Earth, it reinvents the recipe for life in ways we're only beginning to explore. GJ357d defies expectations at every turn. This super-Earth, discovered in 2019, just 31 light-years away, orbits a faint M-type star so dim you could stare right at it without blinking. Yet despite its chilly host, this planet sits squarely in the habitable zone, a testament to how unpredictably life-friendly worlds can emerge. With a mass 6 times Earth's and temperatures likely hovering around -64 degrees Fahrenheit, GJ357d shouldn't be a candidate for life at all. But science loves a paradox, and this icy giant might just hide a secret beneath its thick, swirling atmosphere. What makes this world so intriguing is its balancing act. While its surface would freeze you solid in seconds, the crushing weight of its atmosphere, up to 10 times thicker than Earth's, could create a greenhouse effect powerful enough to trap geothermal heat. Picture a planet where the sky presses down like a lead blanket, where air so dense it behaves like liquid might allow pockets of warmth near volcanic vents or deep underground. On Earth, bacteria thrive in Antarctic ice or beneath permafrost. On GJ357d, entire ecosystems might huddle around subsurface hot springs, shielded from the eternal frost above. The star itself adds another layer of mystery. M-type dwarfs like GJ357 are notorious for their violent flares, yet this particular star is unusually quiet, a cosmic recluse emitting barely a flicker of turbulence. That stability could be the key to preserving an atmosphere over billions of years, giving life time to emerge in slow motion. Even the planet's orbit hints at potential. A year here lasts just 55 Earth days, but its likely tidally locked nature creates stark contrast. One side might glare under permanent, dull starlight, while the other drowns in darkness unless atmospheric currents redistribute enough heat to soften the divide. Then there's the water question. At these temperatures, surface oceans would freeze into global ice sheets miles thick, but beneath that icy carapace, tidal forces from its star could flex GJ357d's core, generating enough warmth to maintain subterranean seas. Imagine a labyrinth of liquid water caves, their walls glowing with extremophile organisms adapted to pressure that would crush a submarine. Or perhaps ammonia or salts lower the freezing point, creating briny rivers sloshing beneath glaciers, a chemical cocktail that might rewrite the rules of biology. The real excitement lies in what we might soon discover. GJ357d's proximity makes it a prime target for atmospheric studies. Future telescopes could hunt for traces of methane or carbon dioxide gases that, in the right ratios, might betray the presence of life silently thriving in the dark. This isn't just another frozen rock. It's a challenge to our assumptions, proving that habitability isn't about mirroring Earth, but about the universe's relentless ingenuity in crafting niches for life where we least expect it. K2-18b shatters everything we thought we knew about habitable worlds. Discovered in 2015, this enigmatic planet orbits a dim red dwarf star 124 light-years away. But it's not the star that makes this world extraordinary, it's what swirls in its skies. When astronomers detected water vapor in K2-18b's atmosphere in 2019, it marked the first time we'd found an exoplanet with both water and temperatures that could support life. But here's the twist, this isn't just another Earth-like rocky world. K2-18b belongs to an entirely new class of planets called Hycean worlds, massive, water-rich globes shrouded in thick hydrogen atmospheres where global oceans might stretch from pole to pole beneath crushing layers of gas. Imagine standing on the surface if you could. The sheer weight of the atmosphere would feel like diving miles beneath Earth's oceans with pressures so intense they'd liquefy metals. Yet beneath that suffocating blanket could lie a liquid water layer dozens or even hundreds of miles deep, kept warm not by sunlight but by the planet's own internal heat and the greenhouse effect of its hydrogen shroud. On Earth, life thrives around hydrothermal vents in pitch-black depths. On K2-18b, entire ecosystems might flicker in perpetual twilight, sustained by chemistry rather than photosynthesis. The planet's 8-day orbit places it snugly in the habitable zone of its faint star, but its true warmth comes from within, a testament to how alien the cradle of life might be. The discovery of water vapor was just the beginning. Recent studies suggest K2-18b's atmosphere might also contain dimethyl sulfide, a gas on Earth produced almost exclusively by marine plankton. While it's too soon to claim proof of alien biology, the mere possibility sends shivers down the spine. Could a planet with no solid surface, no beaches or mountains, still harbor life? Hycean worlds like this challenge our Earth-centric bias, forcing us to consider that the building blocks of biology might assemble in environments we'd once written off as hostile. Yet mysteries abound. That same hydrogen atmosphere, while potentially life-giving, could also act as a cosmic pressure cooker, trapping heat so effectively that the ocean beneath boils away over time. Or perhaps tidal forces from its star churn the waters, preventing stagnation and cycling nutrients through the depths. With a radius 2.6 times Earth's and nearly 9 times the mass, K2-18b straddles the line between super-Earth and mini-Neptune, leaving scientists debating whether it's a water world with a thick gas envelope or a gassy giant with a surprisingly wet disposition. What's certain is that K2-18b has rewritten the playbook. As telescopes like James Webb turn their gaze toward its alien skies, we may soon learn whether those water-laden clouds drift over living seas or a sterile abyss. Either way, this Hycean oddity proves the universe doesn't need Earth's blueprint to craft a world where life could, just maybe, find a way. TOI 700d isn't just another exoplanet, it's a cosmic rarity. Discovered by NASA test mission in 2020, this Earth-sized world orbits a quiet M-dwarf star 100 light-years away, nestled so perfectly in the habitable zone that it's become one of our best shots at finding a true Earth analog. What makes this planet so special isn't just its size or location, it's the serenity of its star. Unlike the violent red dwarfs we've encountered elsewhere, TOI 700 barely flickers, offering a stable, almost gentle environment where life could have the peace it needs to take root. Imagine standing on the surface of TOI 700d, gazing up at a sky washed in perpetual twilight. Its star, a mere 40% the mass of our Sun, casts a dim, reddish glow, enough to keep temperatures in that Goldilocks sweet spot where water could pool on the surface without boiling away or freezing solid. A year here lasts just 37 Earth days, but don't let the short orbit fool you. tidally locked or not, this planet's calm stellar host means it isn't bombarded by the deadly flares that plague so many other M-dwarf systems. The air, if it exists, might cling undisturbed for billions of years, offering a protective blanket against the chill of space. But here's where things get even more intriguing. TOI 700d isn't alone. It shares its star with two siblings, one a likely rocky world hugging the inner edge of the system, the other a mini Neptune lingering farther out. Yet it's this middle child that captivates astronomers. Early climate models suggest that with the right atmospheric composition, TOI 700d could maintain liquid water across its entire surface, creating a global oasis beneath that crimson sky. Some simulations even hint at possible landmasses where continents might rise from shallow seas, their shorelines lapped by waves under a never-setting sun. The absence of stellar flares is a game-changer. Most planets orbiting M-dwarfs face relentless radiation storms, their atmospheres stripped away over time like sand in a cosmic hurricane. But TOI 700's tranquility offers something rare: continuity. If life emerged here, it wouldn't have to constantly reinvent itself to survive flares. Instead, evolution could unfold steadily, perhaps giving rise to complex organisms adapted to the gentle rhythms of a forever dawn world. What's next? TOI 700d is a prime target for the James Webb Space Telescope, which could soon analyze its atmosphere for signs of water vapor, carbon dioxide, or even methane molecules that might whisper of biological activity. Whether this quiet world harbors life or stands as a testament to nature's patience, one thing's certain: it's a reminder that the universe's most promising havens aren't always the loudest. Sometimes they're the ones waiting silently in the shadows, daring us to look closer. Kepler 1649c hides in plain sight, a world so Earth-like it almost feels like science fiction. When astronomers rediscovered this planet in 2020 after an AI sifted through old Kepler Space Telescope data, they couldn't believe their luck. Here, just 300 light-years away, orbits a planet almost identical in size to Earth, basking in the gentle glow of a red dwarf star. But what makes Kepler 1649c exceptional isn't just its dimensions, it's how closely its conditions mirror our own planet's most life-friendly traits. This world completes an orbit every 19.5 Earth days, placing it squarely in the habitable zone of its star. That means the amount of starlight it receives is eerily similar to what Earth gets from our Sun, about 75% as much. Not too hot, not too cold, but just right for liquid water to pool on its surface. And unlike many red dwarf systems where planets are roasted by flares, Kepler 1649c's host star is remarkably calm. Imagine a sun that rarely throws tantrums, offering its planet a stable climate where life could evolve without constant cosmic disruptions. The real magic lies in the details. Kepler 1649c is only 6% larger than Earth, making it one of the closest matches we've found to our own world in terms of size and energy input. Scientists estimate that if it has an Earth-like atmosphere, surface temperatures could average around -64 degrees Fahrenheit chilly, but well within the range where microbes or even more complex organisms might thrive. Picture a landscape where glaciers meet sprawling tundras, their edges melting into rivers that carve through rocky valleys under a perpetual reddish sky. But could photosynthesis occur here? The star's dim, crimson light poses a challenge, but nature is inventive. Plants might evolve to use infrared wavelengths, painting the terrain in deep purples or blacks to absorb every possible photon. Or perhaps life skips sunlight altogether, clustering around geothermal vents like those in Earth's ocean depths. The planet's potential for tidal locking, where one side always faces the star, adds another layer of complexity. Eternal twilight zones along the Terminator line could host temperate bands where liquid water and moderate temperatures create a Goldilocks strip of habitability. The implications are staggering. Kepler 1649c isn't just another exoplanet. It's a masterclass in cosmic mimicry, proving that Earth's recipe might not be unique. Upcoming telescopes could soon analyze its atmosphere for traces of oxygen or methane chemical breadcrumbs that might lead us to the first signs of life beyond our solar system. Whether it's a frozen world clinging to fragile ecosystems or a thriving biosphere we can't yet imagine, one thing's certain: this unassuming planet has rewritten the rules for where life might call home. GJ667cc turns the concept of a sunny day into something out of science fiction. This super-Earth, discovered in 2011, doesn't just orbit one star, it circles a trio of them, painting its skies with a celestial ballet few worlds could imagine. Located 22 light-years away in the constellation Scorpius, this planet weighs in at 4.5 times Earth's mass, with a surface that might just hold one of the rarest treasures in the universe: liquid water. But how does a world maintain stability when tugged by three different gravitational masters? The answer lies in a delicate cosmic dance where chaos and habitability somehow find balance. The primary star, GJ667c, is an M-dwarf, small, dim, and relatively calm compared to its two orange dwarf companions swirling farther out. GJ667cc hugs this red dwarf tightly, completing an orbit every 28 Earth days. That proximity places it squarely in the habitable zone, where temperatures could allow water to flow. But here's where it gets wild. The other two stars, GJ667 and B, orbit each other about 12 times farther out than Pluto is from our Sun, yet their combined glow would still appear brighter than a full moon in GJ667cc's sky. Imagine stepping outside to see not one, but three suns, two golden orbs hanging like distant lanterns beside the dominant red disk of your primary star. Surprisingly, this stellar menagerie might not spell doom for potential life. While multi-star systems were once written off as too unstable for habitable planets, GJ667cc defies expectations. Its orbit remains remarkably steady, shielded from gravitational turmoil by the sheer distance to its stellar siblings. Climate models suggest that with a thick enough atmosphere, something its gravity could easily maintain, this world might redistribute heat efficiently, preventing wild temperature swings. The red dwarf's faintness actually works in its favor too. Unlike hotter stars, it emits mostly infrared light, which could penetrate a hazy atmosphere to warm the surface gently, minimizing the risk of a runaway greenhouse effect. Yet challenges linger. M-dwarfs are notorious for their youthfully violent phases, and while GJ667c is now quiet, it may have bombarded the planet with radiation in its early years. If life exists here, it likely had to endure a brutal adolescence before conditions stabilized. There's also the question of tides. Without a large moon to churn its oceans, nutrient cycling might rely entirely on underwater volcanism or atmospheric currents. What makes GJ667cc truly tantalizing is its composition. Observations suggest it's rich in metals, potentially harboring a molten core that generates a protective magnetic field. Combined with possible geothermal activity, this could create hydrothermal vents akin to Earth's life-filled deep-sea ecosystems. Picture a world where alien organisms cluster around volcanic fissures, their biochemistry adapted to the faint, tripartite light filtering through an alien sky. As telescopes advance, this system will be a prime target. The presence of water vapor or methane in its atmosphere could hint at biological processes, rewriting our understanding of where life might cling in complex star systems. GJ667cc doesn't just challenge the odds, it proves that even in cosmic chaos, nature carves out pockets of possibility. Kepler 452b doesn't just resemble Earth, it taunts us with what could be the closest cosmic mirror we've ever found. Dubbed Earth 2.0, this planet orbits a sun-like star 1,400 light-years away, basking in light almost identical to what washes over our own world. The similarities don't stop there. Its 385-day year is just 5% longer than ours, and it receives only 10% more starlight, placing it in a Goldilocks zone so precise you could call it a cosmic replica. If Earth had a cousin in another star system, Kepler 452b would be it, right down to the possibility of rolling clouds, shimmering oceans, and maybe even continents veined with rivers. What sets this world apart isn't just its familiar rhythm, it's the maturity of its system. Kepler 452, its host star, is 6 billion years old, 1.5 billion years older than our Sun. That extra time could have been a gift to any potential life. Imagine a biosphere with an additional billion years to evolve, refine, and diversify. While Earth's most complex life forms took roughly 4 billion years to emerge, Kepler 452b's head start might have allowed for ecosystems far more advanced than anything we know. Its thicker atmosphere, hinted at by models, could mean denser air rich in oxygen, nurturing larger organisms or even shielding life from cosmic rays more effectively than our own fragile ozone layer. Then there's the geology. Kepler 452b is about 60% larger than Earth, and that extra bulk likely means a molten interior churning with tectonic activity. On our planet, plate tectonics recycle nutrients, regulate climate, and even drive the chemistry essential for life. If this world's crust shifts similarly, it could host towering mountain ranges, sprawling volcanic archipelagos, or vast mineral-rich plains, landscapes where life might find endless niches to exploit. Some scientists speculate its stronger gravity could produce more dramatic features, deeper oceans, thicker continental shelves, or even geysers ejecting water vapor high into a dense, storm-laden sky. But challenges lurk in this paradise. That same aging star, while stable now, has been gradually brightening over billions of years. Kepler 452b might have endured runaway greenhouse effects in its past, or it could be approaching a tipping point where rising temperatures evaporate its oceans. Alternatively, its thick atmosphere could have long ago succumbed to stellar winds, leaving a desiccated husk. The planet's size also raises questions. Does its gravity trap enough heat to sustain a magnetic field, or is its surface bombarded by radiation from its star's occasional flares? The real fascination lies in what we don't know. Kepler 452b's star is bright enough that future telescopes could analyze its atmosphere for biosignatures, oxygen, methane, or even industrial pollutants, hinting at civilizations that had a billion-year head start. Whether it's a living world or a cautionary tale of planetary aging, one thing's certain: this isn't just another exoplanet. It's a time capsule showing us what Earth might become, or what it could have been under a slightly different star. Wolf 1061c defies the odds just by existing. A rocky super-Earth so close we could almost reach out and touch it. Located a mere 14 light-years away in the constellation Ophiuchus, this planet orbits a dim red dwarf star so faint it's invisible to the naked eye from Earth. Yet in that quiet darkness lies a world that could rewrite the rules for habitable planets. Wolf 1061c completes a full orbit in just 18 Earth days, clinging so tightly to its star that you'd expect it to be a scorched wasteland. But here's the twist. It sits right in the middle of the habitable zone, where temperatures might allow liquid water to pool on its surface, if it can survive the cosmic extremes of its environment. The most immediate challenge is tidal locking. Like our moon to Earth, Wolf 1061c likely shows only one face to its star, creating a permanent division between day and night. One hemisphere bakes under endless crimson sunlight, while the other languishes in perpetual frozen darkness. But between these two extremes lies the terminator zone, a narrow ribbon of twilight where conditions might just be right for life to emerge. Picture a world where the sun never rises or sets, but hangs eternally at the horizon, casting long shadows over a landscape of glaciers and temperate valleys. Rivers could flow from the scorched day side, melting just enough to carve through the terminator before freezing again on the night side, creating vast networks of icy braids. But Wolf 1061c's star isn't just dim, it's temperamental. Red dwarfs are notorious for erupting with violent flares, and while Wolf 1061 is quieter than most, it still unleashes enough radiation to strip atmospheres over time. The planet's saving grace might be its size. At 4.3 times Earth's mass, its gravity could hold onto a thick atmosphere, shielding the surface from the worst of the stellar storms. Alternatively, that same atmosphere might trap heat so efficiently that it triggers a runaway greenhouse effect, turning Wolf 1061c into a Venus-like inferno despite its dim sun. Yet life has a knack for clinging to the unlikeliest places. If the terminator zone maintains a stable climate, organisms could thrive along its margins, basking in the eternal glow of a star that never moves. Photosynthesis might look radically different here. Plants could orient their leaves vertically to catch the low-angle light or evolve pigments that absorb infrared wavelengths. Alternatively, life might huddle near geothermal vents, drawing energy from the planet's interior rather than its capricious star. What makes Wolf 1061c truly tantalizing is its proximity. 14 light-years is practically next door in cosmic terms, placing it within reach of future telescopes that could analyze its atmosphere for signs of water or methane. Whether it's a frozen wasteland, a pressure-cooked hellscape, or a twilight oasis teeming with alien biology, one thing's certain: this super-Earth challenges our assumptions about where life can take root and how strange it might look when it does. HD 40307G dances on the edge of possibility, a super-Earth that shouldn't exist where it does. Orbiting a K-type star 44 light-years away, this planet defies expectations with its sprawling, year-long orbit that somehow keeps it perfectly balanced in the habitable zone. Most planets this massive, about 7 times heavier than Earth, hug their stars so closely they become molten wastelands. But HD 40307G takes its time, completing a leisurely 200-day journey around its sun, bathing in just enough warmth to make liquid water a tantalizing possibility. The star itself is a golden key to this planet's potential. K-type stars are often called Goldilocks stars, not too hot, not too cold, but just right for nurturing life. They burn steadily for tens of billions of years, offering planets like HD 40307G a stability that fiery sun-like stars or moody red dwarfs can't match. Picture a sun that glows more amber than yellow, casting a softer, perpetual autumn light over rugged landscapes. But here's the catch: that same gentle starlight means the planet's habitable zone snuggles closer in, forcing HD 40307G to tread a delicate line between warmth and frigid isolation. Then there's the gravity. 7 times Earth's mass means standing on this world would feel like carrying an elephant on your back. Mountains might sprawl lower and wider under the crushing weight, their slopes gentler to compensate for the relentless pull. Trees, if they exist, could grow stouter with trunks like reinforced concrete, their branches arching downward as if in permanent surrender to the planet's might. Even weather would bend to gravity's will. Storms might be shorter but more violent, with rain falling faster and harder, carving canyons in mere centuries where Earth's rivers take millennia. Yet life finds a way. Deep in HD 40307G's hypothetical oceans, the pressure could forge ecosystems unlike anything we know. Organisms might evolve denser cellular structures or even metallic reinforcements in their tissues to withstand the squeeze. Photosynthesis could still thrive under that amber sun, but plants might opt for sprawling ground cover instead of towering forests, their leaves broad and leathery to capture every precious photon. And if the planet's thick atmosphere traps heat efficiently, Tropical bands could host sprawling wetlands where life bustles in the buoyancy of dense, warm waters, a paradise for creatures built like deep sea fish but living in shallow, steamy marshes. The wild card, axial tilt. Earth seasons exist because our planet leans. Without that tilt, climates would stagnate. If HD 40307G lists heavily, its winters could last decades, with ice sheets creeping across continents before being scoured away by equally long, fiery summers. But a minimal tilt might create eternal spring at the poles and endless temperate belts near the equator, a world where migration isn't seasonal but elevational, with life forms climbing mountains or diving into valleys to chase stable temperatures. HD 40307G isn't just another exoplanet. It's a test of extremes, proving that habitability isn't about replicating Earth's specs, but about nature's relentless ingenuity in adapting to, and sometimes thriving in, conditions that would flatten us without a second thought. As telescopes turn toward this golden-starred oddity, we may soon discover whether high gravity breeds high resilience, or if some worlds remain just beyond life's grip, no matter how perfectly placed they seem. Kepler-22b isn't just a planet, it's a piece of history. When this world was discovered in 2011, it became the first exoplanet confirmed to orbit within the habitable zone of a sun-like star, igniting a revolution in our search for alien life. Located 600 light-years away in the constellation Cygnus, this colossal planet dwarfs Earth at 2.4 times its radius, raising a tantalizing question. Could a world this massive cradle life, or is it a gaseous titan with no solid ground at all? The answer might lie beneath its thick, swirling atmosphere, or beneath a global ocean deeper than anything Earth could fathom. Models suggest Kepler-22b could be a water world, its entire surface submerged beneath a single, unbroken sea stretching from pole to pole. Picture an abyss with no continents, where currents circle the planet unimpeded, and storms rage over waves that never crash against land. The pressure at those depths would be crushing, creating exotic forms of ice that behave like hot rock, a realm where chemistry defies our expectations. Yet even here, life might find a way. On Earth, hydrothermal vents in the Mariana Trench host entire ecosystems thriving in eternal darkness. On Kepler-22b, similar vents could dot the ocean floor, their mineral-rich plumes fueling organisms adapted to pressures that would flatten a submarine. Alternatively, Kepler-22b might wear its size differently. Some studies propose it could be a mini Neptune, cloaked in a hydrogen-rich atmosphere so thick it smothers any chance of a rocky surface. But even this scenario isn't necessarily a dead end. Deep within that gaseous shroud, temperatures and pressures might balance to form a layer of supercritical water, a state where liquid and gas blur into one, creating a strange, soupy medium where unconventional life could theoretically emerge. Imagine microbes floating in perpetual suspension, their metabolisms tuned to exploit the chaos around them. The planet's orbit adds another layer of intrigue. Its 290-day year places it comfortably in the habitable zone, receiving about 85% of the sunlight Earth gets. Its star, Kepler-22, is slightly cooler and smaller than our Sun, casting a golden hue over whatever lies beneath those clouds or waves. Unlike the violent red dwarfs that plague many exoplanets, this star is remarkably stable, offering a gentle radiation environment where atmospheres, if they exist, could persist for billions of years. Kepler-22b's legacy isn't just about its potential habitability. It proved that Earth-sized worlds weren't the only players in the game, that super-Earths and mini-Neptunes could also dance on the edge of possibility. Future telescopes might one day dissect its atmosphere, hunting for traces of water vapor or methane that could hint at hidden oceans or even biology. Until then, this pioneering planet remains a symbol of cosmic diversity, a reminder that life's playground might be vaster and far stranger than we ever imagined. Titan B lingers in the cosmic shadows, a quiet achiever in the search for alien life. Orbiting the dim red dwarf Titan star just 12 light-years away, this unassuming world packs a staggering potential within its Earth-like frame. Discovered in 2017, it tips the scales at only 3 times Earth's mass, making it one of the most manageable super-Earths we've found. But what truly sets this planet apart is its improbably cozy position. A mere 25-day orbit around a star so faint you'd need binoculars to spot it from Earth's surface. Yet against all odds, Titan B sits snugly in the habitable zone, where liquid water could pool without freezing solid or boiling away. The secret lies in the star's stillness. Unlike the tempestuous red dwarfs we've encountered, stars prone to flares that scorch nearby planets, Titan star is a cosmic pacifist. It emits barely a flicker of violent radiation, offering its planetary companion a rare gift: stability. Picture a world where the sun never screams, only whispers, a dim, ruby glow that barely warms the face of a tidally locked planet. One side of Titan B might bask in eternal sunset, while the other drowns in endless night. But along the razor-thin terminator line between these extremes, conditions could be just right for life to stake its claim. Rivers might flow from the warm side, freezing as they trickle into the darkness, creating glittering ice bridges under a sky dominated by a star that looks more like a dull ember than our blazing sun. Water isn't just a hopeful guess here, it's a plausible reality. Climate models suggest that with an Earth-like atmosphere, Titan B's equilibrium temperature could hover around -26°F. That might sound inhospitable, but with the right mix of greenhouse gases, heat could distribute efficiently enough to maintain liquid water near the twilight zone. Imagine a planet where glaciers creep toward the light, their edges melting into shallow seas that reflect the star's deep crimson hue. Organisms here might evolve to harvest every scrap of energy from that weak light, their cells fine-tuned to thrive on photons we'd find useless. The real intrigue lies in Titan B's age. Its star is ancient, possibly twice as old as our Sun, meaning this planet has had twice the time to brew life. If biology took root here, it could be far more advanced than anything on Earth, with ecosystems shaped by eons of gradual adaptation rather than catastrophic upheavals. Or perhaps it's a frozen time capsule, preserving primordial chemistry in icy suspended animation. 12 light-years is practically next door in galactic terms, placing Titan B firmly within reach of future telescopes. When we finally peer into its atmosphere, we might find the fingerprints of water vapor, ozone, or even industrial pollutants, hinting at civilizations that had a billion-year head start. Until then, this quiet world serves as a reminder that habitability isn't about stellar grandeur. It's about patience, balance, and the universe's quiet knack for nurturing life in the unlikeliest of corners. Teeming's star B is the quiet underdog of potentially habitable worlds, a planet so Earth-like in mass you could almost mistake it for our own, if not for the alien sky overhead. Orbiting an ultra-cool dwarf star just 12 light-years away, this unassuming world defies expectations by existing at all. Its host star, Teeming's star, is so dim it wasn't even discovered until 2003, hiding in plain sight despite being one of our closest stellar neighbors. Yet this faint ember of a star cradles not one but 2 planets, with Teeming's star B standing out as a prime candidate for liquid water, and perhaps even life. What makes this world remarkable isn't just its size, roughly 1.05 times Earth's mass, but its precarious balancing act. It orbits its star every 4.9 Earth days, a blisteringly short year that would spell doom under a hotter sun. But Teeming's star is so cool and tiny that this tight orbit lands the planet squarely in the habitable zone. Picture a world where the sun is a dull, cherry-red disk barely brighter than a full moon, casting everything in perpetual twilight. Surface temperatures, if an atmosphere exists, could hover near the freezing point of water, chilly but far from hopeless, With the right mix of greenhouse gases, this planet might maintain vast, shallow seas along its equator or nestled in deep valleys where geothermal heat seeps through the crust. Detecting life here, though, is a puzzle wrapped in an enigma. Ultra-cool dwarfs like Teegarden's star emit most of their light in the infrared spectrum, a wavelength range where our current telescopes struggle to analyze atmospheric chemistry. Even if Teegarden's star B boasts oceans and thick, protective air, the dim starlight offers little illumination for traditional photosynthesis. Any organisms might rely instead on chemical energy from hydrothermal vents or harness infrared photons through pigments we can't yet imagine. The planet's likely tidal locking adds another layer of complexity, one side forever facing the star, the other lost in eternal night, creating stark temperature gradients that could drive wild weather patterns between the hemispheres. Yet the very challenges that make Teegarden's star be elusive also make it fascinating. Its star is ancient, possibly twice as old as our Sun, offering life an unimaginable head start. If biology took root here, it could be profoundly adapted, thriving in slow motion under that dim crimson glow. Future telescopes designed for infrared observation might one day glimpse hints of water vapor or methane in its atmosphere, tiny clues that could rewrite our understanding of where life can endure. For now, this quiet neighbor remains a testament to the universe's quiet creativity, proving that even the faintest stars can nurture worlds where life might whisper in the dark. Kepler 1638b whispers the promise of a second Earth, orbiting its sun-like star with an eerie familiarity that sends chills down astronomers' spines. Discovered in 2017 by the Kepler Space Telescope, this world sits 1,800 light-years away in the constellation Cygnus, matching our planet's size almost exactly, a rarity among the thousands of exoplanets we've catalogued. But it's not just the dimensions that captivate scientists, it's the rhythm of its orbit. Kepler 1638b completes a year in 259 Earth days, tracing a path so similar to ours that seasons might unfold there with the same reliable cadence we know, spring blossoms giving way to summer heat, autumn harvests, and winter frosts. The star at the heart of this system could be the key to its potential. Unlike the volatile red dwarfs dominating our exoplanet searches, Kepler 1638 is a G-type star, a near twin to our Sun in temperature and stability. That means sunlight here wouldn't scorch the planet with flares or bathe it in perpetual twilight, but instead offer a gentle, golden glow akin to Earth's midday. Models suggest surface temperatures could hover around 59 degrees Fahrenheit if the atmosphere mirrors ours, cool enough for liquid water to pool without boiling away, warm enough to avoid global glaciation. Picture rolling continents edged by shallow seas, their surfaces rippling under a sun that looks uncannily like our own, yet mysteries linger beneath that inviting veneer. Kepler 1638b's gravity, slightly stronger than Earth's due to its denser composition, could sculpt landscapes in unexpected ways. Mountains might rise taller but with gentler slopes, their bulk compressed under the added weight. Trees, if they exist, could grow thicker trunks to withstand the constant pull, their branches arching downward like cathedral buttresses. Even weather patterns would bend to gravity's will, storms packing more punch but moving faster, their rains falling in sharp, heavy sheets that carve canyons in decades rather than millennia. The true test of habitability lies in water retention. A planet this size could hold onto its oceans for billions of years, but only if shielded from stellar winds. Early data hints at a possible magnetic field, a crucial defense against atmospheric erosion. Combine that with tectonic activity likely given the planet's young, churning interior, and you have a recipe for nutrient cycling that could sustain life as reliably as Earth's own geochemical engines. But here's the twist: Kepler 1638b star is older than ours by nearly 2 billion years. If life arose here, it's had a staggering head start. Evolution under that golden sun might have birthed organisms fine-tuned to conditions we'd find alien, perhaps flora with metallic compounds in their tissues to handle stronger gravity, or fauna with reinforced skeletons to navigate a world where every step feels like carrying an extra backpack. The next chapter of this story waits in the light filtering through Kepler 1638b's hypothetical atmosphere. Future telescopes could analyze that light for traces of oxygen or methane chemical signatures whispering of forests, swamps, or even industrial civilizations that had millennia to perfect their craft. Until then, this world stands as a mirror held up to our own, proving that Earth's recipe might not be unique, just one variation in a universe teeming with possibilities. GJ581g stands as one of the most hotly debated exoplanets ever discovered. A world that might not even exist, found orbiting the red dwarf star GJ581 20 light-years away. This super-Earth sparked both excitement and skepticism when researchers announced its detection in 2010. The controversy isn't about whether it's habitable, but whether it's there at all. Some teams claim it's a clear signal in the data, while others argue it's just noise, a ghost conjured by the complexities of exoplanet hunting. Yet if real, GJ581g could redefine our understanding of where life might thrive in the cosmos. At the heart of the debate is its orbit, just 37 Earth days long, placing it snugly in the habitable zone of its dim star. The planet's gravity, 3 to 4 times stronger than Earth's, suggests it could cling to a thick atmosphere, potentially maintaining liquid water despite the faint starlight. Picture a world where the sun hangs low and red in the sky, casting perpetual twilight over rugged landscapes. Tidal locking would leave one hemisphere scorched by eternal daylight, the other frozen in darkness, but along the Terminator line, temperate bands might harbor lakes or even sprawling wetlands fed by meltwater from glacial peaks. The disputes stem from how it was found. GJ581g was detected using the radial velocity method, a technique that measures the subtle wobble of a star as planets tug on it. Critics point out that the star's own activity, including sunspot cycles and flares, could mimic these wobbles, creating the illusion of a planet. Subsequent studies failed to confirm the signal, leaving GJ581g in limbo, neither fully accepted nor entirely dismissed. It's a cosmic Rorschach test where some scientists see a habitable world and others see stellar interference, yet the possibility is too tantalizing to ignore. If GJ581g is real, its calm red dwarf star, quieter than most of its kind, offers a stable environment where an atmosphere could persist for billions of years. The planet's composition remains speculative, but models suggest a rocky core wrapped in a dense shroud of gases, possibly with water vapor or even oxygen. Life here wouldn't need a bright sun. Underground geothermal vents or chemical reactions in thick atmospheric layers could power ecosystems unlike anything on Earth. The irony, GJ581g's contested status makes it a landmark in astronomy. It's a reminder of how messy and thrilling frontier science can be. Every disputed pixel or wobble forces us to refine our tools, question assumptions, and confront the limits of what we know. Whether this planet fades into myth or emerges as a confirmed haven for life, its legacy is secure. Proof that the hunt for alien worlds is as much about wrestling with uncertainty as it is about discovery. And in that tension, the universe keeps its most profound secrets. Kepler 1229b doesn't play by the rules, a rocky world that turns the harsh reality of red dwarf systems into a potential paradise. Nestled within the Cygnus constellation, over 700 light-years from Earth, this planet orbits its dim star every 86.5 days, basking in just enough warmth to keep water liquid on its surface. But what makes this world extraordinary isn't just its place in the habitable zone. It's the cosmic alchemy of tidal heating that could transform it from a frozen wasteland into a haven for alien life. Picture a planet forever locked in a gravitational tug-of-war. Kepler 1229b's tight orbit around its red dwarf subjects it to intense tidal forces, flexing its crust like a ball of dough kneaded by an invisible hand. This constant stretching generates internal heat enough, perhaps, to melt ice sheets into sprawling subsurface oceans. On Earth, we've found entire ecosystems thriving in the lightless depths of our oceans, sustained by geothermal vents. Kepler 1229b could host similar wonders, its hidden seas warmed not by sunlight but by the planet's own restless core. Imagine hydrothermal vents spewing minerals into pitch-black waters, their plumes feeding organisms that have never glimpsed the dim red sun hanging motionless in their sky. The challenges, though, are as stark as the opportunities. Red dwarfs like Kepler 1229b's are notorious for their violent youth, bombarding nearby planets with radiation that can strip away atmospheres. If this world survived that early onslaught, it might cling to a thin shroud of air just enough to trap heat and shield its surface from the worst of stellar flares. Alternatively, its oceans could be buried deep beneath an icy crust, protected from space's harshness like a cosmic bunker. The planet's likely tidal locking adds another layer of complexity, one side forever scorched by feeble starlight, the other frozen solid, with a ragged edge of twilight in between where temperatures might hover in the sweet spot for liquid water. Yet life, if it exists here, wouldn't need a sunny beach. On Earth, extremophiles flourish in Antarctic ice, acidic hot springs, and even radioactive waste. Kepler 1229b's hypothetical organisms might rely on chemosynthesis, drawing energy from chemical reactions in those tidally heated waters. Their rhythms could sync to the gravitational pulses of their star, their biology fine-tuned to exploit every joule of warmth squeezed from the planet's interior. Photosynthesis, if it occurs at all, might be a fringe adaptation, a desperate hack by organisms clinging to the Terminator's fleeting balance. The real allure of Kepler 1229b lies in its duality. It's both a cautionary tale and a beacon of hope, proof that even in the harshest corners of the cosmos, nature finds a way to carve out niches where life could cling. Future telescopes might one day glimpse traces of water vapor or methane in its atmosphere, hints that this tidal oddity isn't just a geological curiosity but a living world. Until then, it stands as a reminder: the universe doesn't need Earth's blueprint to craft a cradle for life. Sometimes all it takes is a little gravitational friction and a lot of cosmic patience. HD 85512b walks a cosmic tightrope, a super-Earth perched right on the edge of possibility. Orbiting an orange dwarf star 36 light-years away, this planet straddles the outermost boundary of its star's habitable zone, where the difference between a temperate paradise and a frozen wasteland could come down to something as delicate as cloud cover. Discovered in 2011, it's a world that forces us to rethink how atmospheres sculpt climates beyond our solar system. At first glance, HD 85512b shouldn't be hospitable. Its 358-day orbit places it so far from its star that it receives barely 30% of the sunlight Earth enjoys. That's closer to Mars's solar allowance than Earth. But here's the twist: this planet's thick atmosphere, if it has one, might be its saving grace. Models suggest that with just 50% cloud coverage, those swirling vapor blankets could trap enough heat to keep surface temperatures above freezing. Imagine a planet where perpetual overcast skies act like a global insulator, redistributing warmth from the dayside to the nightside and smoothing out temperature extremes. The result, a world where glaciers might lap at the edges of mist-shrouded continents, their meltwater feeding rivers that carve through valleys under a dim, apricot-hued sun. The star itself adds another layer of intrigue. HD 85512 is older and steadier than our Sun, a K-type dwarf that's burned reliably for billions of years with fewer violent flares. That stability could give the planet's atmosphere time to find equilibrium, avoiding the runaway greenhouse effects or atmospheric collapses that plague more chaotic systems. But there's a catch. K-type stars emit more infrared light than our Sun, which means any clouds here would need to excel at trapping long-wavelength heat rather than reflecting visible light. The skies might glow a perpetual dusky orange, with clouds made of salts or sulfides instead of Earth's water vapor, alien chemistry painting an alien climate. Then there's the gravity. At 3.6 times Earth's mass, HD 85512b's pull would sculpt everything from weather to potential life forms. Storms might be slower but more powerful, their winds dragging under the weight of dense air. Mountains could sprawl wider and flatter, their peaks compressed by the relentless tug. Any organisms would need to be sturdier, their structures evolved to handle the constant strain, perhaps resembling Earth's deep-sea creatures, built to endure crushing pressures we'd find unbearable. The real fascination lies in the unknowns. Is this a planet of foggy archipelagos where life clings to volcanic islands in a global ocean? Or a world of high-altitude deserts where only the hardiest microbes survive in thin, icy valleys? With current telescopes, we can't yet see its atmosphere, but future instruments might detect the faint fingerprints of water or carbon dioxide, clues that could reveal whether this planetary tightrope walker has mastered the art of balance or tipped into frozen silence. HD 85512b doesn't just challenge our definitions of habitability. It proves that sometimes the difference between a dead world and a living one is as thin as a veil of clouds. Kepler 1652b tiptoes along the razor's edge of habitability, a world so Earth-like in size it could almost be mistaken for our own if not for the alien rhythm of its days. Orbiting a cool, dim M-dwarf star 822 light-years away, this planet completes a full revolution in just 38 Earth days, a blisteringly short year that would be deadly under a hotter sun. But here's the cosmic sleight of hand. Kepler 1652b star is so faint that this tight orbit still places it in the habitable zone, where temperatures might allow liquid water to cling to existence. The catch, tidal locking, almost certainly pins one face of the planet toward its star forever, creating a hemisphere of eternal daylight and another of unending night. Picture a world divided. On the sunlit side, a scorched landscape bakes under a dull red sun no brighter than Earth's full moon, while the dark side plunges into deep freeze. Yet between these extremes lies the Terminator Zone, a narrow twilight belt where conditions could be just right for water to pool. Imagine rivers fed by glacial melt from the dark side, carving through valleys under skies where the sun perpetually kisses the horizon, neither rising nor setting. These transitional regions might host sprawling belts of habitability, where temperatures hover near freezing but never tip into absolute sterility. Water here would face an uphill battle. The star's faint output means most surface liquids would naturally freeze, unless geothermal activity or an unusually thick atmosphere intervenes. Some models suggest tidal forces could flex Kepler 1652b's interior enough to maintain subsurface oceans, hidden seas warmed by the planet's own friction, like Europa's underground waters but with the added bonus of minimal radiation exposure. Alternatively, trace greenhouse gases in the atmosphere could trap just enough heat to prevent global glaciation, creating patchy oases where microbial life might huddle in briny meltwater pools. The planet's Earth-like dimensions, just 10% larger than our own, add intrigue. That modest size suggests a rocky composition with sufficient gravity to hold onto an atmosphere, unlike smaller worlds where air leaks into space. But red dwarfs are fickle landlords. Kepler 1652b star, while currently quiet, may have bombarded the planet with lethal radiation in its youth, potentially stripping away any primordial air. If life exists here, it likely had to emerge in underground refuges or deep oceanic trenches, sheltered from the worst of space's harshness. What truly captivates scientists is the way Kepler 1652b defies easy categorization. It shouldn't be habitable by traditional metrics, yet its Goldilocks positioning and Earth-like profile make it impossible to dismiss. Future telescopes might one day analyze its atmosphere for signs of water vapor or methane molecules that could hint at geological activity or even biological processes. For now, this world stands as a testament to nature's ingenuity, proving that life's playground extends far beyond the cozy orbits of sun-like stars into realms where twilight is permanent and survival depends on cosmic cunning. Ross 128b might just be the cosmic neighbor we never knew we had, a silent contender in the search for life, hiding in plain sight just 11 light-years away. Orbiting its red dwarf star with quiet precision, this exoplanet punches above its weight, matching Earth's mass almost exactly while basking in the dim glow of one of the calmest stars we've discovered. What makes this world extraordinary isn't just its size or proximity, it's the rare serenity of its stellar host. While most red dwarfs erupt with flares capable of stripping atmospheres and scorching surfaces, Ross 128 simmers like a dying ember, offering its planet a stability that's almost unheard of in such compact star systems. Imagine standing on the surface of Ross 128b, gazing up at a sky dominated by a star so faint it casts little more than a deep crimson twilight. A year here lasts just under 10 Earth days, a blistering orbit that would spell disaster under a hotter sun. But Ross 128's gentle output means this tight dance lands the planet squarely in the habitable zone, where temperatures might allow water to pool without boiling away or freezing solid. The real magic lies in the balance. Models suggest that with even a modest atmosphere, this world could redistribute heat efficiently, preventing the brutal temperature extremes that plague so many tidally locked exoplanets. One side might forever face the star, bathed in perpetual dusk, while the other lingers in icy darkness, but between them, a ribbon of temperate twilight could host conditions ripe for life. The planet's Earth-like mass is another clue to its potential. Unlike larger super-Earths where gravity would crush human explorers, Ross 128b's pull would feel reassuringly familiar. That similarity extends beneath the surface, too. Its rocky composition likely mirrors Earth's, complete with the tectonic activity and mineral diversity that could nurture chemistry essential for life. Water, if present, might gather in shallow seas along the Terminator line, fed by glacial melt from the dark side or underground reservoirs kept liquid by geothermal warmth. But the star's quiet nature is the true game-changer. Most red dwarfs spend their youth unleashing radiation storms that blast nearby planets, leaving them barren. Ross 128, by contrast, is a cosmic elder. Its turbulent days long past, offering its planet a chance to hold onto an atmosphere for billions of years. If life took root here, it wouldn't have to constantly reinvent itself to survive stellar tantrums. Evolution could unfold steadily, perhaps giving rise to organisms adapted to the slow rhythms of a world where the sun never sets or rises, only lingers. The proximity of Ross 128b makes it a prime target for future study. 11 light-years is practically next door in galactic terms, placing it within reach of telescopes that could soon sniff out chemical signatures in its atmosphere, hints of oxygen, methane, or even industrial gases suggesting intelligence. Whether it's a frozen world clinging to fragile ecosystems or a thriving biosphere beneath ruby skies, one thing's certain: this unassuming planet proves that sometimes the best candidates for life aren't the flashiest. They're the ones that endure quietly in the shadows of the cosmos. Kepler 296e doesn't just orbit a star, it shares its cosmic neighborhood with 4 siblings, all dancing around a dim red dwarf in a tightly packed celestial waltz. This 5-planet system, located over 1,200 light-years away in the constellation Lyra, turns the notion of planetary real estate on its head. While most of its siblings hug their star too closely for comfort, Kepler 296e sits in the sweet spot, the only one of its family nestled in the habitable zone where liquid water could exist. But what makes this world truly remarkable isn't just its placement, it's the tantalizing possibility that its entire surface might be a single, unbroken ocean. Unlike planets circling violent stars, Kepler 296e's red dwarf is relatively calm, offering a stable environment where atmospheres and oceans could persist over billions of years. Its 34-day orbit might sound frenetic, but because the star is so faint, this speedy rotation still keeps the planet bathed in gentle warmth rather than scorching heat. Models suggest that with even a modest atmosphere, temperatures here could hover near 59 degrees Fahrenheit, ideal for liquid water to pool across its surface. But here's where the intrigue deepens. Kepler 296e is roughly twice Earth's size, and that extra bulk could mean two things. Either it's a rocky super-Earth with shallow seas lapping against volcanic archipelagos, or it's a water world with no land at all, a planet drowned beneath a global ocean dozens of miles deep. The water world scenario is particularly compelling. Without continents to break up its seas, Kepler 296e's currents might circle the planet unimpeded, creating a climate far more uniform than Earth. Storms could rage endlessly over open water, their energy never dissipating against coastlines, while tides driven by the star's gravity might slosh in planet-wide waves. Life in such an environment would need to be aquatic by default, perhaps evolving in deep, pressurized layers where the weight of water above creates bizarre, high-density ecosystems. Imagine organisms with gelatinous bodies to withstand the pressure, or creatures that harness chemical energy from underwater vents, their biology alien to anything we know. Yet the system's compact architecture raises fascinating questions. The other four planets, all orbiting closer to the star, are likely roasted wastelands, but their proximity means Kepler 296e might occasionally glimpse them as bright dots in its sky. Could gravitational interactions between these worlds create tidal forces that churn Kepler 296e's oceans, preventing stagnation and cycling nutrients? On Earth, life clusters around underwater volcanoes. On Kepler 296e, similar hotspots might be the only places where minerals rise from the depths to feed surface ecosystems. The real test lies in the chemistry. Future telescopes might analyze the planet's atmosphere for signs of water vapor or methane, hints that this isn't just a barren rock but a living world. Until then, Kepler 296e remains a masterclass in cosmic diversity, proving that habitable real estate comes in all shapes and sizes, even as a drop of blue in an endless black sea. Gliese 832c is a study in cosmic contradictions, a super-Earth that could be either a balmy paradise or a climate nightmare, depending on which way its atmospheric winds blow. Orbiting a tranquil red dwarf just 16 light-years away, this planet is tantalizingly close in galactic terms, yet its conditions remain one of astronomy's most heated debates. At 5 times Earth's mass, it's hefty enough to retain a thick atmosphere, but it's the planet's eccentric orbit that really sets it apart. Unlike the near-circular path Earth takes around our Sun, Gliese 832c traces a pronounced oval around its star, creating swings in solar exposure so extreme they could rewrite the rulebook on seasonal changes. Picture a world where summer isn't just warmer, it's apocalyptic. As the planet swings closer to its star during periastron, temperatures might skyrocket by dozens of degrees, boiling off shallow seas or thawing frozen tundras in weeks. Then, as it retreats to the orbit's far end, that same water could flash freeze into glaciers, locking away moisture until the next close approach. These aren't gentle seasonal transitions like Earth's. They're planetary-scale climate whiplashes that could challenge even the hardiest organisms. Yet life, if it exists here, might not just endure these swings, it could exploit them. Some scientists speculate that extremophiles could enter dormancy during harsh phases, only to bloom explosively when conditions briefly stabilize, creating pulsating ecosystems that ebb and flow with the orbit itself. The star's serenity offers a counterbalance to this chaos. Gliese 832 is a rarity among red dwarfs, an elderly, placid star that rarely flares, giving its planets a fighting chance to retain atmospheres over billions of years. That stability is crucial. Without it, the wild temperature variations would have long since stripped away any protective gases. Instead, models suggest Gliese 832c might cloak itself in a dense shroud of carbon dioxide, a gas that could act like a planetary thermostat. During hot phases, CO2 would trap scorching heat, while in colder periods, it might condense into dry ice clouds that reflect sunlight, preventing total freeze-outs. The result, a world that dances precariously between fire and ice, yet somehow remains habitable along the edges. Then there's the axial tilt question. Earth's seasons arise from our 23-degree lean, but Gliese 832 c's massive size and gravitational interactions might leave it wobbling unpredictably. A severe tilt could superimpose additional temperature extremes atop the orbital ones, creating regions that alternate between Saharan heat and Arctic cold within a single revolution. Yet in the right configuration, that same tilt might also moderate the climate. Polar zones could act as cold traps during hot phases, preserving ice that later melts to irrigate the rest of the planet. The ultimate wild card, water distribution. If Gliese 832c has deep oceans, their thermal inertia might buffer temperature swings, creating maritime refuges where life could ride out the extremes. Alternatively, a planet-wide aquifer system could shuttle water underground during droughts, resurfacing when conditions improve. Either scenario would demand organisms with extraordinary adaptability, perhaps resembling Earth's tardigrades, which survive dehydration by entering suspended animation, then reanimate hours or centuries later when water returns. What makes this world truly extraordinary is its test case potential. Future telescopes could analyze how atmospheres behave under such radical forcing, offering clues about climate resilience on other eccentric exoplanets. Whether Gliese 832c is a cautionary tale or a testament to life's tenacity, one thing's certain. It proves that habitability isn't about perfection, it's about persistence, even in the face of celestial chaos. Kepler 283c offers a masterclass in planetary subtlety, a world where habitability hinges on the quiet dance between sunlight and shadow. Orbiting a K-type star over 1,700 light-years away, this Earth-sized planet completes its journey every 93 days, tracing a path that places it squarely in the Goldilocks zone. But what makes this world truly captivating isn't just its familiar dimensions, it's the delicate interplay of light and climate that could transform it from a rocky sphere into a living world. K-type stars like Kepler 283 occupy a cosmic sweet spot. Slightly cooler and dimmer than our Sun, they burn with a golden hue, radiating steadier and longer than their more tempestuous stellar cousins. On Kepler 283c, this translates to a gentler, more consistent glow. Sunlight about 20% weaker than Earth, but still potent enough to sustain photosynthesis if plants here evolved to harness its amber wavelength. Picture sprawling landscapes bathed in perpetual late afternoon light, where vegetation might adopt deeper greens or even coppery tones to optimize energy capture. The star's stability is another gift. Unlike the violent flares of red dwarfs, this sun offers a calm environment where atmospheres can persist for billions of years, undisturbed by the radiation storms that ravage other systems. The planet's size suggests a rocky composition with Earth-like gravity, but its climate could diverge wildly from our own. Kepler-283c's orbit is slightly more elliptical than Earth's, creating subtle seasonal shifts in temperature, not the extreme swings of Gliese 832c, but enough to sculpt distinct biomass. Summers might stretch longer and milder, while winters remain brief but crisp, especially at higher latitudes. Without large moons to stabilize its axial tilt, the planet's poles could wander over millennia, alternately melting and refreezing to redistribute water across its surface. Water itself is the great unknown. If Kepler-283c holds onto substantial oceans, their thermal inertia might buffer those seasonal changes, creating maritime climates akin to Earth's Pacific Northwest, misty, temperate, and teeming with life. Alternatively, a drier world might feature sprawling savannas where rivers pulse with seasonal rains, their banks lined with organisms adapted to feast or fast with the rhythm of orbital eccentricity. The planet's rotation speed adds another layer of intrigue. A slower spin could mean longer days and nights, fostering nocturnal ecosystems where creatures navigate by bioluminescence or infrared senses. The true test of Kepler-283c's potential lies in the chemistry of its skies. Future telescopes might hunt for traces of ozone or methane, hints of an atmosphere not just surviving, but actively cycling elements in ways that could betray biology's handiwork. For now, this world stands as a quiet testament to the universe's versatility, proving that even under a gentler sun, the alchemy of rock, light, and water can whisper the same tantalizing question: is anyone home? Captain B doesn't just orbit a star, it circles a relic from the dawn of the cosmos itself. This super-Earth, discovered in 2014, clings to a faint red dwarf known as Captain Star, a celestial wanderer that doesn't truly belong to our galaxy's main spiral. Instead, it drifts through the galactic halo, a sparse outer region populated by ancient stars cast adrift during the Milky Way's violent infancy. At an estimated 11 billion years old, Captain Star and its planetary companion are more than twice the age of our solar system, making them time capsules from an era when the universe was still piecing together the ingredients for life as we know it. Picture a world that's witnessed the bulk of cosmic history. When Captain B first formed, galaxies were still taking shape, colliding and merging in the chaos of the early universe. Its host star likely began life in a dwarf galaxy devoured by the Milky Way, a survivor of celestial carnage now drifting alone through the halo. The planet itself, 5 times Earth's mass, orbits every 48 days in a region where temperatures could against all odds permit liquid water. But here's the mind-bending part. If life arose here, it's had 11 billion years to evolve. That's more than double the time Earth's biosphere has had to tinker with biology. What might emerge given such an unimaginable head start? The possibilities are as staggering as they are alien. Complex life on Earth took roughly 4 billion years to reach intelligence. On Captain B, evolution could have cycled through countless experiments, perhaps birthing civilizations that rose and fell before Earth's continents even formed. Their technology, if any persists, might be unrecognizable to us, a blend of organic and synthetic, or forms of energy manipulation we can't yet fathom. Alternatively, life here could have settled into an equilibrium so perfect that innovation ceased to be necessary, leaving a planet-wide ecosystem frozen in harmonious stasis. Yet the challenges are equally profound. Captain Star, though ancient, is still a red dwarf, a type known for lethal flares in its youth. The planet may have endured billions of years of radiation storms before its star settled into relative calm. Any surviving life would need extraordinary resilience, perhaps sheltering deep underground or beneath ice sheets for eons before emerging into a more hospitable era. The planet's strong gravity could also shape biology in radical ways, favoring low, sturdy life forms or creatures built to withstand constant pressure. The most haunting question isn't whether life exists on Captain B today, it's what traces might remain of civilizations that flickered out billions of years ago. Future telescopes could analyze its atmosphere for industrial gases or artificial isotopes, hunting for fingerprints of intelligence that predate multicellular life on Earth. Whether a graveyard of lost empires or a living museum of primordial biology, this ancient world forces us to confront a humbling truth. We might not be the universe's first or even its most profound experiment in consciousness. Kepler 1544b is a lesson in cosmic restraint, a world that could be either a tranquil oasis or a silent wasteland, all depending on the whims of its diminutive red dwarf star. Discovered in 2016 by the Kepler Space Telescope, this Earth-sized planet orbits its faint sun every 12 days, a breakneck pace that would vaporize oceans under a hotter star. But here's the paradox: because its host star is so small and cool, that frantic orbit lands Kepler 1544b squarely in the habitable zone, where temperatures might allow liquid water to cling to existence. Picture a world caught in perpetual twilight, bathed in the dull crimson glow of a star barely larger than Jupiter, a sun so faint that noon would feel like Earth's deep dusk. The real intrigue lies in the planet's potential for water retention. At almost the same size as Earth, Kepler 1544b likely possesses similar geology, a rocky surface where continents could rise from primordial seas. But red dwarfs are notorious for their violent youth, and this star may have bombarded the planet with radiation for its first billion years, stripping away any initial atmosphere. If Kepler 1544b held onto its water through that stellar onslaught, it might now host shallow oceans nestled in deep basins, their surfaces protected by a thin but tenacious shroud of greenhouse gases like carbon dioxide. Alternatively, its water could be locked beneath an icy crust, with only geothermal hotspots, volcanic fissures, or hydrothermal vents keeping it liquid in isolated pockets. Tidal locking adds another layer of complexity. Like most planets orbiting red dwarfs, Kepler 1544b likely shows only one face to its star, creating a permanent division between scorching dayside and frozen nightside. Yet along the Terminator line, the razor-thin border between light and dark conditions might be just right for liquid water to pool. Imagine a ring of habitable real estate encircling the planet, where glaciers from the dark side slowly melt into rivers that flow toward the dayside, only to evaporate under the relentless crimson sun. Life here would cling to equilibrium, thriving in the narrow band where temperature and chemistry align. The star's current calm offers a glimmer of hope. Unlike younger red dwarfs that erupt with deadly flares, Kepler 1544b's host appears relatively quiet in its old age, a stellar retiree content to glow faintly rather than rage. That stability could allow any surviving atmosphere to persist, shielding the surface from cosmic rays and creating a buffer against temperature extremes. But the planet's past remains a haunting question. Did it endure an early apocalypse only to emerge as a late blooming haven, or is its surface a sterile monument to lost potential? Future telescopes might glimpse the answer. By analyzing starlight filtering through Kepler 1544b's atmosphere, scientists could detect traces of water vapor or oxygen chemical breadcrumbs hinting at hidden oceans or even photosynthetic life adapted to the star's dim glow. For now, this world stands as a testament to patience, proving that even under the faintest stars, the universe writes stories of resilience in water, rock, and time. GJ3293d defies the odds, a super-Earth that shouldn't be habitable, yet clings stubbornly to the possibility of life. Orbiting a dim M-dwarf star just 59 light-years away, this planet carves a niche in the habitable zone despite a year lasting only 48 Earth days. That blistering orbit would spell doom under a hotter star, but GJ3293's faint glow turns the impossible into plausible, offering just enough warmth for liquid water to exist if the planet plays its atmospheric cards right. What makes this world so intriguing is its thick, soupy atmosphere, a near certainty given its mass at least 7 times heavier than Earth's. That crushing gravity would trap gases like a cosmic vault, creating a pressure cooker where air behaves more like liquid than gas. Picture skies so dense they refract light into eerie halos, where clouds of water vapor or even ammonia might hover just above mountain peaks. The surface, if one exists beneath those swirling layers, could harbor oceans kept liquid not by sunlight alone, but by the greenhouse effect run amok. Heat trapped so efficiently that even a dim star's glow becomes enough to stave off global glaciation. Yet the challenges are as thick as the air. M-dwarfs like GJ3293 are notorious for their tempestuous youth, bombarding nearby planets with radiation that can strip atmospheres down to bare rock. If this super-Earth weathered that early storm, its atmosphere might now be a relic, a primordial shroud of hydrogen and helium left over from formation, or a secondary blanket of CO2 belched from volcanoes over eons. Either scenario raises tantalizing questions. Could life adapt to such extremes? On Earth, microbes thrive in hydrothermal vents where pressures are hundreds of times greater than at sea level. GJ3293D's hypothetical organisms might float in those dense skies, their biology fine-tuned to harvest energy from chemical reactions in the atmosphere itself, like cosmic jellyfish drifting through an endless opaque ocean. The planet's tidal locking adds another layer of complexity. One side forever faces its star, basking in dull crimson light, while the other plunges into eternal night. But that thick atmosphere could be the great equalizer, redistributing heat from day to night so efficiently that the extremes soften into something survivable. Imagine a world where hurricanes the size of continents rage endlessly along the Terminator line, their winds ferrying warmth and moisture between hemispheres. Life might cluster in those turbulent borderlands, where temperatures hover near equilibrium and liquid water could condense into shallow seas or mist-laden valleys. The real wild card is time. GJ3293 is a relatively quiet M-dwarf, offering its planet a stable environment where atmospheres and any potential life could persist for billions of years. If biology took root here, it might have had epochs to experiment with forms we can't yet imagine. Future telescopes could hunt for clues in the planet's transmission spectrum, analyzing how starlight filters through its atmosphere to reveal the fingerprints of water, methane, or even industrial pollutants hinting at intelligence. GJ3293D isn't just another exoplanet. It's a laboratory for nature's most extreme experiments, proving that life's playground extends far beyond the cozy orbits of sun-like stars, into realms where air is thicker than water, and survival depends on atmospheric alchemy we're only beginning to understand. Now, as we reach the final world on our list, prepare for a revelation that could redefine everything we thought we knew about habitable planets. The 30th and most astonishing candidate isn't just promising, it shatters the boundaries of where we imagined life could thrive. This isn't merely about distance from a star or the presence of water. It's about an environment so alien, so counterintuitive, that its mere existence forces us to rewrite the textbooks. What awaits is a world where the rules of habitability don't just bend, they break entirely. Kepler 174d stands as a testament to life's tenacity, a world so distant and frozen it defies conventional wisdom, yet whispers hints of habitability from the shadows. Orbiting its star over 1,100 light-years away, this icy enigma completes a year in 513 Earth days, tracing a path so far from its sun that surface temperatures would plunge to hundreds of degrees below zero. But here's the twist. Beneath that frozen crust, Kepler 174d might hide an ocean of liquid water, kept warm not by sunlight, but by the relentless flexing of its own core. Imagine a planet where the surface is a barren, icy wasteland, where geysers of nitrogen frost erupt into skies too thin to scatter light. Dig deeper, though, and you'd find something extraordinary, a subterranean sea, perhaps dozens of miles thick, its waters heated by tidal forces as the planet's orbit tugs at its molten interior. On Earth, we've found life thriving in the most improbable places, buried under Antarctic ice in boiling acidic springs, even inside nuclear reactors. If organisms exist on Kepler 174d, they might cluster around hydrothermal vents on the ocean floor, their biology adapted to exploit chemical reactions in place of sunlight. These wouldn't be creatures as we know them, but something stranger, perhaps gelatinous life forms buoyed by the dense, saline waters, or colonies of microbes forming vast, living mats that pulse with geothermal energy. The star itself adds another layer of intrigue. Kepler 174 is smaller and cooler than our Sun, a dim ember that bathes its planets in faint reddish light. But this very faintness might be the key to the planet's hidden warmth. With minimal solar radiation to disturb its icy shell, the subsurface ocean could remain insulated for billions of years, a cosmic incubator where life could experiment with forms we've never imagined. The ice above wouldn't just be a barrier, it might act as a protective shield, sealing the ocean away from the vacuum of space while allowing just enough geothermal heat to seep through and sustain liquid water. Then there's the composition. Kepler 174d's density suggests a mix of rock and ice, with a core rich in radioactive elements like uranium and thorium. These minerals could decay over time, releasing heat that further warms the depths. Picture a world where the ocean floor is dotted with volcanic vents, their plumes of minerals feeding ecosystems entirely cut off from the surface. No sunlight, no seasons, just an eternal, pitch-black abyss where life evolves in slow motion, shaped by chemistry rather than celestial cycles. The real marvel is the timescale. Kepler 174d's star is ancient, offering this planet eons to refine whatever life might lurk beneath its ice. If biology took root here, it could have had twice as long as Earth's biosphere to explore evolutionary possibilities. What emerges after billions of years in such isolation? Organisms with metabolisms slower than glaciers, or perhaps hyper-efficient chemotrophs that have perfected energy extraction from the barest whiff of sulfur or iron. What we're glimpsing here isn't just another exoplanet. It's a paradigm shift, proof that the universe doesn't need tropical shores or golden sunlight to cradle life. Sometimes all it takes is a little friction, a little heat, and an ocean hidden in the dark, waiting for us to rethink everything we thought we knew about where life can thrive. From scorching super-Earths to frozen worlds with hidden oceans, these 30 planets redefine what it means to be habitable. Kepler 186f paints a picture of Earth's crimson twin, while Proxima Centauri b lurks just next door, a reminder that alien life could be closer than we ever imagined. TRAPPIST-1e dazzles with its sibling worlds hanging in perpetual view, and K2-18b shatters expectations by proving water-rich planets might not need solid ground at all. We've seen worlds drenched in eternal twilight, planets with 3 suns in their skies, and even ancient survivors like Captain B time capsules from the universe's fiery youth. Each challenges our Earth-centric assumptions, revealing that life's playground could be vaster and stranger than we dared to dream. What ties them together isn't just their Goldilocks positioning, it's their stubborn refusal to surrender to cosmic extremes. Life, if it exists on these worlds, isn't waiting for perfect conditions. It's squeezing opportunity from tidal heat, clinging to razor-thin terminators, or thriving in crushing atmospheric depths. These planets don't just expand the search for alien biology, they force us to rethink life's very definition. Could organisms harness infrared light instead of sunlight? Could intelligence evolve in oceans without shores? The more exoplanets we discover, the clearer it becomes. The universe is a master of reinvention, crafting habitats where we least expect them. The future of this search burns brighter than ever. Telescopes like James Webb are already peeling back the atmospheric layers of these distant worlds, hunting for chemical signatures, oxygen, methane, even industrial pollutants that could betray alien activity. Missions like Habitable Worlds Observatory aim to directly image Earth-like planets, while Breakthrough Starshot dreams of sending probes to our nearest stellar neighbors. Every technological leap brings us closer to answering humanity's oldest question: are we alone? But perhaps the most profound revelation isn't about distant planets, it's about us. This cosmic census of habitable worlds holds up a mirror to Earth's fragility and rarity. We're surrounded by possibilities, yet so far, ours remains the only world confirmed to pulse with life. That paradox is both humbling and electrifying. It invites us to cherish our pale blue dot while daring us to keep searching, questioning, and marveling at the wonders still hidden in the starry dark. The universe has shown us 30 doors. Behind any one of them, life might be waiting, not as we know it, but as we're only beginning to imagine.